Okay, so example 1. The spinner is spun 35 times. Number 4 occurs 12 times. What's the experimental probability that the spinner lands on 4? So we already spun this 35 times. And so the experimental probability of getting a 4, in our experiment, we did 35 trials. We spun this 35 times. How many times did we land on the 4? So how many times did we land on the 4? So the experimental is 12 over 35. You can use a calculator, of course, and change that to whatever, to change that to 8%. All right, so we have 12 divided by 35, and it's give us 40%. Or I can write 40%. All right, now, how does it compare to theoretical probability? Well, theoretical probability, in theory, when we just look at it based on facts, so again, the theoretical, and I write theoretical over here. So before we do the experiment, and if I were to ask you what's the probability landing on 4, you would say, well, the probability landing on 4 is 1 out of 5. And 1 out of 5 is the same thing as 20%. So in our experiment we got 12 out of 35 or 40%? Do we get more or do we get less? We got more. So the experimental was definitely more than we expected. So we can also use the theoretical to predict. So if the probability of landing on 4 is 1 out of 5, and I'm going to spin it 35 times, we can make a prediction, right? So 1/5 times 35 is 7. So it was supposed to land on 4 7 times, but how many times did it land? It landed on 12, so it landed actually 5 more. Okay, the spinner spun 40 times, so again, we spun this 40 times, and it stopped in the letter J 8 times. So the experimental probability, right, so it's, we're looking for the experimental probability of J. So in our experiment, we did this 40 times, and it landed on J 8 times. So 8 divided by 40, and you can say that it was 20%. So 20% in our experiment landed on 8. So, but again, theoretically, the probability landing on J, well, it's 1 out of 4. And 1 out of 4, if you divide that, the probability of landing on J, the theoretical probability of landing on J is 1 over 4, or 25%. So again, you can already tell that it landed on J less than it was supposed to. It landed only 20%. It was to land 25%. So if we use our experimental to predict, so we have 1/4. And how many times are we going to spin? So this is before the experiment, times 4, 40, and 10 times. So we were expecting 10 times. And how many times did it land on J? It landed 8. How many less? 2 less. Okay. Explain your own. What is the difference between experimental and theoretical probability? So you can write that on URL. Experimental obviously is based on an experiment, and theory is based on facts before you actually perform the experiment. So you can write that down. A coin is flipped 20 times. So, and in our experiment, so the experimental probability of landing on heads. So in our experiments, how many times did we flip the coin? We flipped it 20 times. And how many times did it land on head? 12 times. Our theoretical probability, before I do the experiment, what was the probability of landing on heads? Well, the probability of landing on heads in our theoretical probability is 1 out of 2. What's the difference between the two probabilities? Well, if I can make a little prediction here, my prediction is, well, half, right? The theoretical probability landing on heads is half. And if I multiply by that by 20, which is the number of times I'm going to flip the coin, I was expecting the coin to land on heads 10 times. And how many times did it land on heads? 12 times. So it was definitely 2 more in our experiment. A player has 36 free throws attempted so far this basketball season. He made 27 of these attempts. The next time the player goes to shoot a free throw, what is the probability that the player will make a free throw? So the probability of him making the free throw Well, this is going to be based on um, the all the free throws that he made throughout the games prior to today. So prior to today, he tried that 36 times, and he was successful 27 times. So 27, he's the probability of him making that the free throw is going to be 27 over 36, and if you change that to percent, is he has a 75% chance. So when he goes to shoot the ball, we can say he has a 75% chance of making, which is pretty good. The spinner spun 50 times, so we have a spinner here. It's going to go around 50 times. So the experimental, so there's an experiment here. And we're looking at P of 50, P of even. So in our experiment, we did it 50 times. And how many times did we land on even? 15 times. So that's letter A. Letter B, what's the theoretical? Well, in theory, before you do the experiment, theoretical, if I were to ask you what's the probability on landing on an even number, you would say, well, there is 1, 2, 3, 4, 5 even numbers out of 10. So you would say the theoretical probability of landing on even is 5 out of 10, or 1 out of 2, or 50%. Right? Let me just change that top one. 15 divided by 50 equals, and then in our experiment, how many times did he land on even? 30%. So you can already see that in the experiment, you got a little bit more than expected. What's the difference between the probabilities? Well, the theoretical, it was half, right? The probability of landing on even, it was half. We assume it was half. And how many times are we going to spin it? 50 times. So before the experiment, if you were to figure this out, half times 50 is 25. You were expecting it to land on heads 25 times. Did he land on head 25 times? No, he landed on head 15 times. So it was definitely less. How many less? 10 less, because we're expecting 25 and landed only on 15, only 15 times. A number cube is rolled 60 times. So again, there was an experiment, and we are looking for a number that's less than 3. Less than 3 would be 2 and 1. So the probability of landing on less than 3 is probably of 1 or 2. And how many times did he land on 1 or 2? 25 times. 25 times out of 60. So, and again, I don't know if you have to change it to percent, but it's nice and easy to compare. So he landed on 1 or 2, 41.67% of the times. What's a theoretical probability? Well, the theoretical probability is that theoretical probability of P of landing on 1 or 2, because you want all the numbers that are less than 3, right? So theoretical probability, sorry, everything's okay. 1 or 2 is, well, there's 2, right? 1 or 2, 2 out of 6, or 1 out of third, or 33.33%. So did he land 33? Did he land on 1 or 2 33.33% of the time? No, he landed a little bit more in our experiment, right? So what's the difference between the two probabilities? Well, if our theoretical, in theory, before you actually did the experiment, you would tell me, hey, well, it's going to land on 1 or 2 1/3 of the time, and if we spin this 60 times, and you multiply, so our prediction, 1/3 times 60, you were expecting it to land on a number less than 3, 20 times. Did he land 20 times? No, he landed 25 times. So it was a little bit more. So the difference is 5 more. Here is a workout. So a workout playlist on an iPod had 13 R&B songs and 7 gospel songs. So there's just 2 different types of music. And each day during an exercise, the playlist is put on shuffle mode. Over the past 10 days or last 10 days, this first song played has been an R&B song 7 times. So, if you have 13 R&B songs and 7 gospel songs, so this is no different than saying there's 13 red marbles and 7 blue marbles. It's the same thing. Instead of marbles, we're talking about songs. So if you had this, in your phone or your music player, and I ask you, what's the probability that if you press play right now, what's the probability of it playing an R&B song? Well, the probability of an R&B song right now is, how many R&B songs are there? 13 out of, what's the total? 20 songs. So there's a 13 over 20 chance, and that's a 65%. There's a 65% chance that it's going to play an R&B song. So that's the theoretical probability. What was the experimental probability? Well, the experimental probability, and I'll write experimental, the probability of an R&B song. Well, the last 10 times, how many times did you play this? Did you press play? Once every once every day for the past 10 days. So in the past 10 days, you press play, and how many times did an R&B song come up? Well, an R&B came out how many times? 7 times. So your experimental probability was 7 out of 10. Was that a little bit higher? Yes, it was, because 7 out of 10 is the same thing as 70%. Okay, so what was, no, there's no other question, that's it. Write an example that illustrates the difference between an experimental probability and a theoretical probability. So this could be on anything. So you flipped a coin 10 times, flip coin 10 times, and in your experiment, the P of, let's just make heads, was 3. You got heads 3 times out of the 10. And meanwhile, your theoretical, what would your theoretical probability say? Well, the theoretical probability says that if I throw a coin up in the air, the probability of landing on heads is a half, or 50%. And this actually was 30%, right? So out of 10 times, if you were to flip a coin 10 times, how many times would you expect it to land on heads? It'd be 5, right? Because half times 10 is 5. So your prediction, half times the 10 times that you're going to flip the coin, and it should have landed on heads 5 times. Did it land on head 5 times? No, he landed on head how many times? 3. So the experimental was a little bit less than the theoretical prediction. A coin is, oh well, we have an example. A coin is flipped 10 times, the coin lands on head 7 times. Write the values fraction and percent form. So what's the experimental probability of this experiment? Well, the experimental probability of landing on heads in the experiment, it landed on heads 7 out of 10 times. What was the theoretical? Well, theoretically, if I want to throw a coin in the air, how many times, what's the probability of getting heads? Well, the probability of getting or landing on heads would be 1 over 2, right? So if I do now a little prediction, so based on that information, I'm going to use half, right? The probability of landing on heads is half. And if I'm going to throw the coin 10 times, half times 10 is 5. How many times should it land on heads? It should land on heads 5 times. Did it land on head 5 times when you flip the coin 10 times? No, it landed on head 7 times. So it was a little bit more than expected. 2 more, actually. A baseball player has hit 5 hits in the last 25 at bats. So he goes to try to hit the ball, and he hit the ball 5 times out of 25. Based on this information, how many times can the player be expected to get a hit on his next 35 at bats? So experimental probability, right? Here's an experiment. What's the probability of getting a hit on his when he goes to when he's at bat? Well, the probability so far, well, he had 25 tries, and how many times did he make contact with the ball? 5 times. 5 out of 25 is 1 out of 5, or if you want to write this, 20%. Or if you simplify this, you get 1 out of 5 or 1 out of 5. So based on this information, I'm going to make a prediction. So 1/5 is the probability that he's going to get a hit times, and how many times he's going to go at bat? He's going to go at bat again 35 more times. So in the next 35 times that he goes, if we multiply 1/5 times 35, we expect him to have 7 hits. Okay, so I use his previous 25 at-bats to make a prediction on his next 35 at-bats. The spinner is spun 80 times, and an even number occurs 24 times. So in the experiment, P of even, how many times did he land on even? 24 times out of 80. And if we change that to a decimal, 24 divided by 80, we're going to get 30% or 30%. So that's the experimental probability. Now the theoretical, and I'll write it here, the theoretical probability. What's the probability of getting an even number? Before we do the experiment, and you're just looking at this, and I ask you, what's the probability of getting an even number? You would say, well, there is 1, 2, 3, 4, nope, 4, 5 even numbers out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 10. So the probability of getting an even number is a half, or 50%. So 50% of the time, it should land on an even number. So if I am going to make a prediction here, so half, how many times are we going to spin this? 80 times. So if you spin this 80 times, I'm going to predict that it's going to land on a even number. Half times 80 is 40 times. Did that actually happen? Did it land on an even number 40 times? No, it didn't. How many times did it land? 24. So what was the difference between these two? 40 minus 24? 16 times. That was the difference. A number cube is rolled 30 times. A number less than 3 is rolled 25 times. Why do I feel like we just... Oh, okay. Sort of the same. So a number cube is rolled 30 times. A number less than 3 is rolled 25 times. So less than 3 would be 1, 2, 3, 4, 5, 6. Less than 3 would be this one and this one. So in our experimental probability, in the experiment, right, you actually did a little experiment. You rolled the number cube 30 times. The probability of less than 3 to get a number less than 3. How many times did you do this? 30 times. And how many times was a number less than 3 achieved? You got that 25 out of 30 times. So, and 25 out of 30, you can change it. Let's change it to percent. 83.33%. What was the theoretical probability? Well, the theoretical probability of less than 3 in theory. So if you were to look at a die and I ask you what's the probability of getting a less than 3, which is 1 and 2, you would have a 2 at a 6th chance, which is 1/3, which is as a percent 33.33%. What was the difference? Well, let's do a prediction here. Well, in theory, I expected to land on a less than 3 1/3 of the time. How many times are we going to roll this? 30 times. 1/3 times 30 is 10. So I was expecting a number less than 3 10 times. Did it happen 10 times? No, it happened 25 times. So much more than expected. What was the difference? 15 times. And again, we go to the same scenario. This iPod has 15 R&B songs and has 5 gospel songs. So that makes it how many songs? 20 songs. Every day during the exercise, you put the playlist on shuffle. Over the last 4 days, the first song played has been an R&B song only once. What's the theoretical probability that the first song will be an R&B song? So theoretical. So if you look at your music and you see, oh, I have 15 R&B songs and I have five gospel songs. So if I were to press the play button, what's the chance that an R&B song is going to play? Well, there's 15 R&B songs. How many total? 20. 20. 20. So it's 15 out of 20, which is 75%. If I make a prediction now, I can use 15 over 20 or 3/4. I'll write 3/4. So in my prediction, if I get 3/4, and how many times I'm going to press play? I'm going to press play 4 times over the past 4 days. Over the next 4 days, if I press play, 3/4 times 4 is 3. So I'm expecting that if I press play 4 times, 3 of those times is going to be an R&B song. Did that actually happen? Let's see. So over the last 4 days, the experimental probability, here's experimental probability of getting an R&B song. Over the last 4 times I press play, how many times did an R&B song come up? It says an R&B song only once came out, only once. So it was 1 out of 4. So in 4 days, an R&B song played 1 time. What was my prediction? I was expecting 3 times. So this was definitely less. There's an extension here. Henry's playing a game using a bag of tokens that contain 28 black tokens and 12 white tokens. So I'm going to write 28 black, 12 white, and that gives me a total of 40 tokens. So every time a single player's turn, a single token is drawn at random from the bag and then returned to the bag at the end of the turn. So we're going to take one, look at it, and put it back in the bag. So this is definitely independent. Each token is the same size and shape. He recorded the first 10 draws. So Henry did this experiment. He took one, it was a black, put it back in. Took another one, it was a white, put it back in. Took another one, it was a white again, put it back in. So he repeated this experiment 10 times. Based on the information given, what is a theoretical probability of the next player drawing a white token? Well, in theory, okay, so forget the experiment right now. Let's focus here. I have 28 black and 12 white. So if I want to find the probability of a white token, what's the chance of me getting a white token? Well, it'd be 12 out of 40, right? So that's a theoretical. Now, based on the information given, what's the experimental probability of the next player drawing a white token? So based on the experiment, all right, so this is the experimental probability. What's the probability of getting a white? Well, the probability, according to this information here, and I'm going to focus here, out of 10 times, how many times did we get a white? 1, 2, 3, 4. 4 times. So the experimental probability is 4 out of 10 or 40%. Okay. Are there more questions? Henry says that only by decreasing the number of black tokens in the bag, the theoretical probability of drawing a white token can be made equal. I gotta make this smaller because I have no idea. Can be made equal to the experimental probability of drawing white token. Well, let me go back. The experimental, so in my experimental. The experimental probability of drawing a white token, what was based on the experiment, it was 1, 2, 3, 4. 4 out of 10 times you would get a white one. Now, what's the theoretical probability of getting a white? Well, how many tokens did we have? We had 28 black and 12 white. So we had 28 black. So in theory, the theoretical, 28 black and 12 white. So theoretically, the probability of getting a white is 28 out of 40, and 28 out of 40 is 70% or 70%, 0.7 or 70%. So so the question is saying how do I change the number of tokens here so that I can get this number and this number to match. So I need the experimental probability to be 7 out of 10. Oops. Right? So 70% was the theoretical, so I want my experimental to also be 70% or 7 out of 10. So how do I change this? Well, he's saying that the only way to change it was to decrease the number of black tokens. So he has a point here. So in order for this to be 7 out of what do you call? Hang on a second. So only decrease the number of black tokens. How this theoretical to drawing the white tone can be made equal to the experimental. Oh, I see. So sorry. The experimental was 4 out of 10. So how do I make this over here also be 4 out of 10, which is 40%? So somehow I gotta change my theoretical to 40%. And he's saying that he should be removing black tokens. Yes, and we had 28 black and 12 white. So in order to make this we gotta change the number of black tokens. Well, to change the number of black tokens, we gotta make this 40%. Hang on a second. 3. So that's 40%, which means 10. Why is this 40%? 40, 50, 60, 70, 80. 1, 2, 3, 4. So we would have to make the black ones 1, 2, 3, 6, 9, 12, 15, 18. I make that 18. So if I change the number of black tokens to 18, let's see what happens. If I were to ask you what's the probability of getting a white, you would say, well, the probability of getting a white is 12. Well, white is 12 out of 30 because now there are 30 tokens, and it's 12 out of 30, 40%. Yes, it is. I got this right. All right, so by removing some of the black tokens, okay, you change the denominator and you make the chance of getting a white a little bit better. Okay, a little bit less. Sorry, a little bit less. Okay. So Henry uses the original bag of tokens that contain 28 black and 12 white. He says only by increasing the number of white, the theoretical probability of drawing a white can be equal to the experimental probability of drawing a white. Ugh. Okay, so in the experiment, the probability of getting a white was 1, 2, 3, 4, right? He reached into the bag 10 times. So P of white is 4 out of 10. And that's the experimental, right? In the experiment, the probability of getting a white was 4 out of 10. In the theoretical, we had 28 black and 12 white. There is right now, a 12 out of 40 chance of selecting a white, and 12 divided by 40 equals 30%. So right now we're at 30%. Right, so how many whites should I increase so that I get 40%? If we add, if we add well, this is incorrect because if we add 4, we'd have to decrease the number of whites by the same amount. to keep it at 40, and that would not work. So if you made this 16, right, which is 40% of 40, 16 white, and you make that, obviously, I'm going to increase this plus 4 and this minus 4, right? So 4 plus 12 is 16, and then 28 minus 4, sorry, I should have written over here. 28 minus 4 is 24. I still have 40, marbles in token, 40 tokens in total, but now I have 16 divided by 24, which is 67.67%, which is not gonna help. Okay, so, and that's that. Hopefully, whoever gets to watch this later can check their answers. Let me stop this.